So confidence intervals basically just tell us how confident, how sure we can be that the mean kind of lies between these two numbers. And it says, according to our central limit theorem, approximately 95% of the sample means fall within 1.96 standard deviations of the population mean if the sample size is 30 or more. So we're focusing right now on being 30 or more. Or if the standard deviation is known, or n is less than 30, but the population is normally distributed. Basically, all of this means is you've got to make sure that you have your sample sizes greater than 30 for it to be kind of trustworthy. So normally, and what we've been working with so far, is confidence levels of 90, 95, and 99%. There's other ones. Now remember, it's based off that standard normal distribution. So it says the Greek letter alpha represents the total area in both tails. So if we want 95, or in this case 98%, there's 98% here, means 2% or 0.02 is made up in the tails. And if you divide that in 2, alpha over 2, you get 0.01. So if you want to find the 98% confidence interval, you're going to go change it to a decimal and then go 1 minus it to get 0.02. Why? Because that's what's out here on the outside. What it ends up being, so it says, so alpha over 2 is 0.02 divided by 2, or 0.01. If you were to look on a table, we're going to use actually 0.990 because our alpha, this outside here, well, we'll say, okay, remember, the table is going to tell us up to this line right here. So this is 98%, and then this is another 0.01%. So we have to add it up. And we get 0.99. So if you look just on the positive side, that's all we do on our normal distribution on that table, is 0.9901 as close as we could get. So that would leave our z alpha sub 2, or whatever it is, to be 2.33. So even if they weren't going to tell, or we weren't going to be able to use our standard ones, our 90, 95, and 99%, we could still find it. Okay. And again, we're only going to use the positive z value. Something else that's going to happen is that we're not going to necessarily always use the standard deviation sign. Sometimes you're going to use S. Okay? Not things I'm overly concerned with, but just so you're aware of. This is just if is it 90, 95, or 99%, because remember, we have right here, we have these, our z sub alpha over 2, we have those intervals, and you can just use those, 1.65, 1.96, 2.58. And this right here would be our z sub alpha over 2. Correct? Yeah. Alright, let's look at an example. Now it says the following data represents a sample of the assets of 30 credit unions in Pennsylvania, southwestern Pennsylvania. Find the 90% confidence interval of the mean. Well, there's a way to find mean and standard deviation in your calculators. Mean might not be too hard, but it's kind of a pain, I know, to do standard deviation. So if you know how to do that on your calculators, awesome. If not, come talk to me and we'll figure it out together. But basically what this comes down to is if I were to add them all up and divide by how many there are, 30, our mean would be 11.091. My standard deviation, and I would just get this from my calculator, or you could figure it out, is 14.405. Now, our z sub alpha over 2, that's again based on our 90% confidence interval. Now if you go back to whatever those confidence intervals were and the numbers that were attached to it that we just looked at, the formula for confidence interval, you can see that 90% is at 1.65. Now, once you identify all these numbers, remember, here's your formula. The mean minus the z sub alpha over 2 times the standard deviation divided by the square root of the sample size. It's going to be less than the mean, because again, we're trying to find the interval that the mean is going to be between. The mean minus z sub alpha over 2, and I'm sorry, that should be plus. This one's minus, this one's plus. Standard deviation over the sample size. So if you plug your numbers in, what we end up with, okay, and again, I'm just using these numbers I found. I do need a square root of n. N is going to be 30, because that's how many in our sample size. And then do the same thing over here with a plus sign. Divided by the square root of 30. Phew! Actually, when you figure it all out though, what it ends up being is 6.752 is less than the mean, which is less than 15.430. Now remember, our focus was on 90%. So what does this mean? We can be 90% confident the mean of the assets, right up here, is between, now I had 6.752, but it was in millions, 6.752 million, and do the same thing over here, 15.4430 million. Okay, so we can be 90% confident that our mean is going to fall between those two numbers. Okay, again, if you have the ability to kind of figure out this information, go ahead and use that. So, again, our focus right now is going to be on the fact that we want to use 30 or greater than for our sample sizes, and if we do that, we can kind of use these numbers for 95% or whatever it is. And if we don't have the percentage of 90, 95, or 99, we can still figure it out using our standard normal distribution.